Alright, welcome to the write a paragraph proof. So based on the flow proof you wrote in the previous section, you can now write a paragraph proof. Following is a sample of a paragraph proof for a very short proof. Read the proof and then use it as a guideline to write your own paragraph proof from your flow proof. So here's the sample. Given that angle CAD is a right angle and that B lies in the interior of angle CAD, prove that angle CAB and angle BAD are complementary angles. So given that point B lies in the interior of angle CAD, we know that the measure of angle CAB plus the measure of angle BAD equals the measure of angle CAD by the angle addition postulate. Then, since we are given that angle CAD is a right angle, we know that by the definition of right angles, measure of angle CAD is equal to 90 degrees. Therefore, using the substitution property of equality, we can replace the measure of angle CAD with 90 degrees to get the measure of angle CAB plus the measure of angle BAD equal to 90 degrees. The definition of complementary angles is that there are two angles whose measures have the sum of 90 degrees. Therefore, the angle CAB and angle BAD must be complementary angles. Now use your flow proof and your plan for the proof to write a paragraph proof for the given and proved statements below. Enter your answer in the text box below. Press the check answer button when your answer is complete. Remember that you may refer to this list of postulates, terms, properties, and definitions if you forget any of them as you build the proof. So it says, given that the segment CE is transformed to segment ED by 180 degree rotation about point E, segment AE is transformed to segment BE by 180 degree rotation about point E, the distance of AD is equal to the distance of BC, measure of angle A equals 30 degrees, measure of angle B is equal to 30 degrees, angle C is transformed to angle D by a 180 degree rotation about point E. Prove that triangle AED is congruent to triangle BEC. Alright, so here is the flow proof. So to break this up, I would first start off with this. Given that segment CE is transformed by segment ED by 180 degree rotation about point E, we know that a rotation is an isometry definition, which is the definition of an isometry. So we're going to start off by using this and just putting it into English. So if we do that, we're going to have, given that segment CE is transformed to segment ED by 180 degree rotation. So given segment CE is transformed to segment ED by a 180 degree rotation about point E. That is what was given. Then we know, so I'm following this arrow right here, then we know that segment CE is equal to the distance of ED because a rotation is an isometry, and that's the definition of an isometry. So that is what we will state next. Oh boy. Oh, right there. Okay. About point E. So then the distance of CE equals the distance of ED by the definition of an isometry. Because a transformation is an isometry, and by definition of an isometry, the distance of CE equals the distance of ED. Period. So then, now we're coming back up here. So then, by definition of congruent segments, we know that segment CE is congruent to segment ED. Right here. So by definition of congruent segments, segment CE is congruent to segment ED, period. Okay, so that's our first part. The next thing that we're going to do is we're going to start off on this part. So then we're going to move to this one, and we were going to say the same thing. Given that segment AE is transformed to BE by 180 degree rotation at about point E, we know that, so we're going to flow this one now. So let's jump over here. I'm going to actually just copy this and paste it because it's the same setup as the first one. Notice that it's the same reasons given. It has the exact same thing. It's the exact same setup. So that's why I'm copying it. Now I'm just going to change it to segment AE and segment BE about point E. So given that segment AE is a transformation by the point BE, BE by 180 degree rotation about point E, because the transformation is an isometry, and by the definition of an isometry, the distance of CE equals the distance of, so this will be the distance of AE is equal to the distance of BE. By the definition of congruent segments, then we know that AE is congruent to segment BE. The reason I can do that is because, like I said, the information is the exact same, just with different points. So now I'm not going to be able to copy again because this one is different. So it says that the distance of AD is equal to the distance of BC, which is given. So we're going to start there now. So, given that the distance of AD is equal to the distance of BC. Given the distance of AD equals the distance of BC. Okay, and then it goes to here. Then it says, alright, well, definition of congruent segments. So then we can say, by the definition of congruent segments, segment AD is congruent to segment BC. So we can go from here to here. Given the distance of AD equals the distance of BC, and the definition of congruent segments, segment AD is congruent to segment BC. So that's our next one, and we're just going to keep following this flow proof. So the next one that is building is this one, and this one. The reason I'm saying they go together is because they have this right here. So we would say this together. Given that the measure of angle A is equal to 30 degrees and the measure of angle B is equal to 30 degrees, that's where we're going to start. So given the measure of angle A is equal to 30 degrees and the measure of angle B is equal to 30 degrees. And given this, then it leads us to this next one. It's saying that using the transitive property, we know that the measure of angle A is equal to the measure of angle B. So that's what we'll say. So that's what we're going to go and say. By the transitive property, property of equality, angle, measure of angle A equals measure of angle B. So now we're here, and now we're going to go follow where it says, and now we're going to say by definition of congruent angles, we have that angle A is congruent to angle B. So by definition of congruent angles, angle A is congruent to angle B. Alright, so that's that section of the flow chart. And then we have two more things because these ones were combined. This one is not combined by anything, so we're just going to start here. So given that angle C is a transformation to angle D by point E, alright, that's what we're going to start with. So now we're going to say, given that, and I gotta scroll up, so we're right here on the given part. Given that angle C is transformed to segment D by a 180 degree rotation about point E, what did that lead us to? Well, it led us to that a rotation is an isometry, and that the definition of an isometry, we can say that the measure of angle C is equal to the measure of angle D. So we're just following what this says. We're going to first state what is in the dark green box and then follow it by our conclusion. And that's how, pretty much, I hope you've noticed that in the last few, that is the pattern. You state what's in the green and end with the light green. State what's in the green, end what's in the light green. State what's in the green, end with what's in the light green. So, there, period. And given that angle C is transformed to segment D, and that a transformation is an isometry, using the definition of an isometry, or by the definition of an isometry, the measure of angle C is equal to the measure of angle D. So now again, we're going to move to the next set. By definition of congruent segments, we can conclude that angle C is congruent to angle D. Alright, by definition of congruent segments, angle C is congruent to angle D. And then now we're moving on to the next setup of our flow statement. By definition of vertical angles, angle AED and angle BEC are vertical angles. So that's what we would state. By definition of vertical angles, angle AED and BEC are vertical angles. And angle BEC are vertical angles. Then we follow what it leads to. By the vertical angle theorem, then we know that angle AED is congruent to angle BEC. So by vertical angle theorem, angle AED is congruent to angle BEC. And then, by definition of congruent triangles, we have that triangle AED is congruent to triangle BEC because we proved each of these individual parts so that we could use the definition of congruent triangles. So by definition of congruent triangles, triangle AED is congruent to triangle BEC. And that's how you would convert your flow proof into a paragraph proof. So on this, just note that paragraph proofs, you start with the dark green, move and put that into English, and move to the light green, putting it into English, and then you just follow the flow and make sure that you have proven every single one of these before you can use this combination one right here for the final conclusion. This is your final conclusion right there.